Good morning. I am Dr. A. AROKIAMARY, Assistant Professor, PG and Research Department of Mathematics, St. Joseph's College of Arts and Science, Autonomous, Cuddalore. I am going to teach Fourier series in the interval 0 to 2 pi. Let f of x be defined in the interval c less than x less than c plus 2 pi with period 2 pi and satisfy the following conditions known as Dirichlet's conditions. That is, f of x is single valued. Second one is it has finite number of discontinuities in a period of 2 pi. Third condition is it has a finite number of maxima and minima in a given period. Fourth one is integral c to c plus 2 pi modulus of f of x dx is convergent. If f of x satisfies the above conditions, then it is possible to express f of x as f of x equal to a0 by 2 plus summation n equal to 1 to infinity an cos nx plus summation n equal to 1 to infinity bn sin nx. This expression of f of x is called Fourier expansion or a Fourier series. Now the coefficients a0, an, bn are given by a0 equal to 1 by pi integral c to c plus 2 pi f of x dx, an equal to 1 by pi integral c to c plus 2 pi f of x cos nx dx, bn equal to 1 by pi integral c to c plus 2 pi f of x sin nx dx. If c equal to 0, then the interval of definition for f of x is 0 to 2 pi. And in this case, a0, an, bn are given by a0 equal to 1 by pi integral 0 to 2 pi f of x dx, an equal to 1 by pi integral 0 to 2 pi f of x cos nx dx, and bn equal to 1 by pi integral 0 to 2 pi f of x sin nx dx. Let us see an example. If f of x equal to pi minus x by 2 the whole square defined in 0 to pi, then show that f of x equal to pi square by 12 plus summation n equal to 1 to infinity cos nx by n square. Deduce that 1 by 1 square plus 1 by 3 square plus 1 by 5 square plus etc. infinity equal to pi square by 8. Given f of x equal to pi minus x by 2 the whole square. And we know that the Fourier expansion is f of x equal to a0 by 2 plus summation n equal to 1 to infinity an cos nx plus summation n equal to 1 to infinity bn sin nx. Where a0 is 1 by pi integral 0 to 2 pi f of x dx, that is 1 by pi integral 0 to 2 pi f of x is pi minus x by 2 the whole square dx. That is 1 by, here we have 2 in the denominator, squaring this will get 4. So 1 by 4 pi. When we integrate pi minus x whole square, it is pi minus x whole cube divided by minus 3. The limit is 0 to 2 pi. And so the value is 1 by 4 pi. When you apply 2 pi here, pi cube by 3. Again for lower limit 1 minus sign, so plus pi cube by 3, that is we get it as pi square by 6. To find an, which is 1 by pi integral 0 to 2 pi f of x cos nx dx. So it is 1 by pi integral 0 to 2 pi pi minus x by 2 the whole square into cos nx dx. That is 1 by 4 pi integral 0 to 2 pi pi minus x whole square into cos nx dx. We are going to apply Bernoulli's formula. Let u equal to pi minus x whole square and dv is cos nx dx. Now u dash, when we differentiate pi minus x whole square, we get 2 into pi minus x. Then again for minus x we get a minus sign. So it is minus 2 into pi minus x. And u2 dash, when we differentiate this again, we will get 2x. So when we differentiate we get it as 2. When we integrate dv, that is when we integrate cos nx, we get sin nx by n. Again integrating v, for sin nx it is minus cos nx by n. So already we have one n minus cos nx by n square. Again integrating this, minus sin nx by n cube. By Bernoulli's formula is uv minus u dash v1 plus u2 dash v2, etc. So an equal to 1 by 4 pi uv, that is pi minus x whole square. V is sin nx by n, then minus u dash v1. U dash and v1 has already minus into minus plus, and in the formula we have a minus, so minus 2 into pi minus x into minus 1 into minus cos nx by n square, and then plus u2 dash v2. u2 dash is 2 and v2 is minus 1 square into minus sin nx by n cube. Now the limit is 0 to 2 pi, that is 1 by 4 pi into pi minus x whole square sin nx by n minus 2 into, when we multiply these two we get positive sign, so minus 2 into pi minus x into cos nx by n square, then minus 2 into sin nx by n cube. When we apply the upper limit, we get for sin multiples of 2 pi is 0 and sin 0 is also 0. Therefore the first and last term is 0, and for the middle term we get pi. When you apply 2 pi we will get plus, okay, plus 2 pi by n square, cos n 2 pi is 1. And for lower limit we get minus as plus, so plus 0 when you apply 2 pi, cos 0 is 1 divided by n square. So we get 2 pi by n square. When we add these two, we get 4 pi by n square. 4 pi gets cancelled. We get it as 1 by n square. To calculate Bn, it is 1 by pi interval 0 to 2 pi f of x sin nx dx. So it is 1 by 4 pi interval 0 to 2 pi pi minus x whole square into sin nx dx. Again we are going to apply Bernoulli's. U is pi minus x whole square. U dash is minus 2 into pi minus x. U2 dash is 2. dv is sin nx dx. When we integrate, it is minus cos nx by n. v1 is minus sin nx by n square and v2 is cos nx by n cube. So Bn is uv 1 by 4 pi into uv, that is pi minus x whole square into minus cos nx by n, again minus 2 into pi minus x into minus sin nx by n square, then plus u2 dash v2, that is plus 2 cos nx by n cube, 0 to 2 pi. For sin we will get it as 0. Sin multiples of 2 pi is 0 and sin 0 is also 0. For the first term, when we apply 2 pi, we get pi minus 2 pi is pi square. Here we get a minus sign, so minus pi square divided by n. Cos multiples of 2 pi is 1. And then the last term, 2 into cos multiples of 2 pi is 1, so 2 by n cube. And lower limit, minus of minus plus, and pi minus 0 is pi, so pi square by n. Again for this last term, the lower limit is minus 2 by n cube. So we get it as 0. That is, we get f of x is a0 by 2 plus summation 1 to infinity an cos nx plus summation 1 to infinity bn sin nx. Bn is 0 and a0 is pi square by 6. So a0 by 2 is pi square by 12 plus summation 1 to infinity 1 by n square. An is 1 by n square. So 1 by n square cos nx. This is what we have to prove. Then there is a reduction. So to find that reduction, put x equal to 0. We get, if you put x equal to 0 here, we will get pi square by 4 equal to pi square by 12 plus 1 by n square. That is summation 1 by n square equal to pi square by 4 minus pi square by 12. When we simplify, we will get pi square by 6. That is 1 by 1 square plus 1 by 2 square plus 1 by 3 square etc. up to infinity is pi square by 6. Put x equal to pi. When we put x equal to pi, left side is 0. Here we will get cos n pi is minus 1 power n. So we get it as minus 1 power n by n square. Okay, so 0 equal to pi square by 12 minus 1 by 1 square plus 1 by 2 square plus 1 by 3 square etc. Or we can write 1 by 1 square minus 1 by 2 square plus 1 by 3 square etc. equal to pi square by 12. Adding these two, we get twice, okay, the even terms gets cancelled. 1 by 2 square, 1 by 4 square, those terms gets cancelled and we get twice 1 by 1 square plus 1 by 3 square plus 1 by 5 square etc. infinity equal to pi square by 6 plus pi square by 12, that is 3 pi square by 12, or the summation equal to pi square by 8. This is what we have to prove. Thank you.